Hello, my name is Pierre Martinez.
And my name is Antonio Flores. And for our Networks Project 2, we wanted to design and build a flow-based network traffic monitoring system using NetFlow inside a simulated GNS3 environment. Instead of focusing on a specific company or a specialized industry, our goal was to create an overall general purpose monitoring setup that reflects how real enterprise networks gain visibility into traffic behavior.
This project focuses on how flow-based monitoring can reveal metrics such as, but not limited to, bandwidth usage, application behavior, and congestion patterns more efficiently than packet-level tools. Modern networks carry a wide variety of different traffic, including web browsing, background updates, DNS queries, and general control traffic. As networks grow in size, they also grow in complexity, and so it becomes increasingly difficult to understand overall behavior using packet-level analysis alone.
And while existing tools like Wireshark provide detailed visibility into individual packets, they don't really scale well for identifying higher level trends such as top traffic sources, dominant protocols, or changes in traffic over time.
So packet level monitoring is extremely useful for debugging specific issues, but it becomes inefficient when analyzing larger volumes of traffic or trying to understand overall network behavior. Network administrators often need answers to questions such as which hosts generate more traffic, which protocols are the most active, and how traffic moves between network segments. Flow-based monitoring addresses these challenges by summarizing traffic into flows, reducing complexity while also preserving meaningful information.
Yeah, so we chose this project to better understand how NetFlow works in practice and how flow data just differs from the traditional packet captures. Building the network system in GNS3 allowed us to safely experiment with routing, switching, and monitoring tools in a controlled environment. And this project also required some self-learning, configuration and troubleshooting beyond just like what we covered in class. And this just helped us reinforce real-world networking skills. Our network follows a simple but realistic enterprise layout consisting of a core router, multiple access switches, several end hosts, and a centralized collector. The core router acts as the point for all traffic, and it's responsible for exporting NetFlow records. Layer 2 switches connect and Layer 2 switches connect end hosts within each subnet, while routing between subnets is handled directly by the router.
And these subnets represent different traffic zones, allowing us to observe both intra-subnet and inter-subnet communication. A dedicated collector virtual machine is placed in a separate management subnet. This design allows us to prevent normal client devices from directly accessing the monitoring system and reflects common best practices used in real networks.
The traffic generated by nhost passes through the router, where NetFlow records are created and exported to the collector. This ensures centralized visibility while keeping the design simple and scalable.
The project was built using several tools and technologies. GNS3 was used as a network simulation platform, and a Cisco iOS router was configured to export NetFlow version 9. Layer 2 switches provided access connectivity, and virtual PCs or VPCSs were used to simulate client devices generating traffic.
An Ubuntu server virtual machine was also used as the NetFlow collector with NTOPNG installed for flow processing. Wireshark was used for packet level traffic capture and validation. NetFlow configuration and collector setup were self-taught components of this project. It required us to consult external documentation beyond just what we did in the course. Multiple simulated PCs were placed in different subnets to generate traffic. ICMP traffic was generated using ping to test connectivity, routing, and inter-subnet communication. Traffic was generated both within a single subnet and across subnets to ensure routed flows were captured by NetFlow.
As traffic was generated, the router aggregated packets into flows and exported summarized flow records to the collector. This allowed us to observe source and destination addresses, protocol types, and overall traffic patterns without capturing every packet. To validate the flow data, Wireshark was used to capture packets on network links and compare them directly with NetFlow statistics on the router. Basic security and segmentation principles were incorporated in the design. the collector was placed in a dedicated management subnet, isolating it from the normal client traffic, and this prevents end hosts from directly accessing the monitoring system and reflects common enterprise design practices.
Routing all the inter subnet traffic through the core router ensured that NetFlow captured meaningful communication patterns. This separation reduced unintended interference during testing and just improved traffic visibility. The completed system successfully demonstrated the benefits of flow-based monitoring. NetFlow made it easy to identify traffic sources, observe protocol usage, and understand communication patterns between subnets. These insights required a lot less effort compared to deriving the same information from packet captures alone.
Wireshark provided detailed packet level visibility for validation, while NetFlow also offered a scalable summary of network behavior. Together, these two tools demonstrated how packet level and flow level analysis complement each other. This project was completed as a group effort with a clear division of responsibilities.
I designed and implemented the GNS3 topology. I helped partly configure the routing and switching. I enabled NetFlow on the router, and I integrated the Ubuntu-based collector virtual machine. And I also just helped author the report and the presentation.
I was able to research NetFlow concepts. I also partly configured routing and switching. I designed the traffic generation scenarios and performed Wireshark analysis. And I too helped author the project report and presentation.
This project demonstrates how flow-based monitoring using NetFlow provides scalable and meaningful insight into network traffic behavior.
By combining routing, switching, traffic generation, packet capture, and flow analysis, all within GNS3, we created a realistic monitoring environment that reflects real-world practices and extends beyond just packet level analysis.
And now we'll be moving on to the demo. Did you do it?